A new day, a new project, a new experiment, of course, and here I have, let's call it the first step of my future headphones amplifier. That's a modified tone control board. I have volume and I have treble, middle and bass. I changed this to operational here with some original GRC 4565DD, so these are old stock, I may say. All the parts are checked, and I may say this guy gives a really nice sound. And the next step will be a headphones driver, a small amplifier, I may call it, power amplifier, to have some more signal to the headphones. But you see, I need some AC at the input here. And the schematic it's saying AC 12 volts, at least 12 volts, because we have two linear power regulators here. You know, the classic the schematic with 791 and 781 plus minus 12 volts. And of course, we need a transformer. I was looking in between my stuffs. I couldn't find anything proper, but a transformer which gives me 2 times 7.5 volts. That's not enough for this schematic. We can give a try and measure the voltages. So my goal for today is to open the transformer and change the secondary to my needs. I'm pretty sure this guy is working with these voltages too, but you see, doesn't have whole amplitude. Okay, power off. There's no danger here as long as we are not connected to the mains. Power on. Yeah, obviously we got power there. You can see the LED is not very happy with these voltages. Let's count for AC first. And we got 7.6, 7.6, 15 totally. And what about the DC? 9 volts, 8.2, 9.12. Huge difference. How comes? 8.22. That's not the right voltage. I should have at least 12 volts. So my dear friends, nothing else to do but to try to dismantle this transformer and rewind the secondary. The primary, it's absolutely okay. Let's see about the resistance. 540 ohms. That's perfect. Okay, we have to take all these metallic things apart. I'm trying to get these wings something sharper. Careful with these sharp things. You see, the transformer had been coated with some lac, and that makes everything difficult, but not so difficult. Okay. Now let me try to open these guys. We already have some movement here. So I believe luckily that varnish doesn't went too much inside or too deep, and we can take these iron parts very easy apart. Maybe we should try, but I don't want to, you know, to disturb mechanically too much of this. Okay, so here we are. All the metallic parts are away, and now we can access the secondary right here. Okay, so here we have the outputs of the coils. Very nice done, by the way. Obviously we don't need that. First step, of course, it's to measure what kind of wire do we have here. So for that I'm using a micrometer. This is a 0.4 millimeters wire. Well, it gives me a lot of power, of course, but there is not enough room to fit another coil. All right, so let's put this to 0. You see, what's nice about this manual winding machine is that we can reverse the counting. So now I have to find out how many winds I got per volt here. They did the winding with two pieces of wire in the same time. Okay, we are on 0 now, and we can safely take everything out without caring, counting. There are not so many, so and that's it. And we have 100 minus 17. We have 83 rounds, 83 to 7.5 volts. Now we have to divide 83 divided by 7.5, and that gives like 11.06 turns per volt. AC 12 volts. Okay, so that means, let's say 11 times 12, 132, okay, times 2, 264 rounds. Okay, let's start doing it. Like I said so many times before, improvisation is an art. Okay, let's see what we got here. Is it working or not? Okay, there we go. Of course, the machine should be better stabilized, but for now I don't have any other way to use it. $142, let's give it 150. We have some more room for the regulators, you know, to do a proper job. And here we are in the middle of the things. Let me have this 151. Okay, let it be like that. So let's remember that, and let's have another round of 151. That gives me like 13 volts, which is even better to have enough room for the regulators, you know, to work properly. And we don't need more than 200 milliamps, so this kind of wire will do the job perfect. That's it. Okay, there we are. Yeah, that should be fine. So this is the middle, and this is one of the beginnings, and the other one and the end. I don't see any problem there. Nothing left but to have all these iron parts inside, and of course okay, so everything is back in the case, so we got nothing else to do but to try to thin a little bit the terminals here, and to start analyzing or measuring, in fact, the voltages, and of course to hook it on the board. This one goes in here, a screwdriver. There we go. So middle to one of the arms, 13.8, 14.8. Perfect. And now let's see the DC voltages. We should have 2 times 12 volts. Here is one, 12.09, and the other guy, 12.11. Well, guys, this is a perfect transformer, and that's a perfect setup for this kind of board. Like I told you, the next one, it will be a headphone amplifier connected to this. Eventually, a nice case, and build myself a headphone amplifier with tone control. The point is that you need to use real OPs, operational circuits, because you know, the Chinese one are 99% fakes, We don't need those in this kind of audio chain. So a little update, 1 hour later, the transformer is warm, but we should have a thermal camera. I should use my thermal camera to see about the real temperature. Like I said, 1 hour later, and the transformer have like 45 degrees Celsius, and we have like 35 degrees on the operationals. And what about the regulators here? I can't get that, but anyway, it's like same story, 35 degrees. So it shouldn't be a problem. You know, for a transformer like that, 45 degrees, it's absolutely okay. I'll be back with the whole project when it's finished, of course, and also we're gonna have some tests. Thank you for now. Please don't forget to subscribe to my channel, like, and of course, be creative and have fun. Bye bye.